Daniel Schiller from Fraunhofer IPA, and Daniel is the research associate leading handling processes and dexterity at Fraunhofer IPA. And Daniel has got an MSc in Mechatronic Systems from the University of Applied Sciences in Munich, and he's also got an MSc in Engineering Cybernetics from the University of Stuttgart. Daniel's expertise is in simulation, computer vision, AI solutions, and he's got 10 plus years of experience specifically in the automotive industry and having worked with the likes of BMW and Daimler. And Daniel's focus is on bin picking, virtual robo optimization, geometric optimization, and clustered object detection, all of this which comes together in the AI bin picking solution. Daniel, it's such a privilege that you could join us today. Thank you.
Thank you for being here.
And this takes me to the part where we put over to Daniel for the real life demo, where you see how the system works and you get some impression how easy it is to set up the system. So Daniel, now it's your turn to show how this works.
Yes, thank you, Richard. If we can switch over to my screen, where I already prepared the user interface. Yes, that's great. So just that you know, I have the screen on my left side. That's why I will look most of the time on the left side, because I have to control it. Okay, so let's start and set up a simple project. The user interface looks a little bit different from the version you saw in the presentation. Of course, we are still doing updates and are improving our system constantly. So let's create a new project, just an example project for now. Here is our example project. Description is not so important for now. But here, as you can see, we have a quite variety of robots already available from different robot companies, KUKA, ABB, FANUC, QR, and so on. So we are not really limited here. You can see here, these robots are really implemented. It's easy to add even more with an UIDF. This is something experts do. That's why you cannot change anything here. We have to be a little bit precise with UIDF files. So we limit the options here so you don't mess up your robot settings. See here, we have different robots already included and so on and so on. But let's go with our KUKA for now. For now, we have three different grippers prepared in the back end. It's easy to add new grippers, but this is something I would put for now as an expert thing as well. You have to be, it's simple to set up, it's fast to set up, you just have to be precise with some settings. Otherwise, you will not see any result at all and you will not know why. Camera, easy, we can work with different companies, but for now, Photoneo and Civit are generally good camera and 3D systems. Just a 3D object, just our bin workpiece. Of course, we started a new project, so we don't have a workpiece now. But let's add a new one. Of course, I prepared something. Here we have an example object we can use. Really easy, you see our object here. Actually, I think 10 gram or a little bit less. Let's increase it to 100 gram, have it here. Here's my project. We can remove it again and add it again. Really easy to do and fast, and oh, now it's 10 gram. Our environment currently is missing the robot because I probably forgot to click on save and continue. Yes, that was the reason I forgot to click on save and continue. But actually our bin picking cell is still missing, so let's upload one as well. You need the STL files for it, but here it is. And now in the 3D viewer, quite easy to move the objects around. We can rotate them as well if we like. Do some, I think now it's completely messed up on that. Yeah, but let's go back to 0, 0, 0. 0, 0, 0, even though let's go back with the rotation. Yes, and we are back in our default position. So even if you mess up things, it's not that hard to fix them. So So we can move them manually with our mouse within the viewer or with our settings here. So yeah, let's keep it how it is for now. Now let's go to the parameters. We have simplified things a lot for the typical user. We want to give you as less options at the beginning as possible, so it's easy to set up. And we actually want to hide most of the things from a normal user. We still have them in the admin parameters here. There are quite a lot more parameters and admin extra parameters. So in case something does not work or you want to simulate something a little bit more sophisticated, we can tell you what you can change, or we can log in and set it up ourselves. For normal user, really easy. I want to have an example with 30 work pieces, 100 cycles. The start of the simulation is not so important for the starting number of work pieces, not so important for the reproducibility study, but for the data generation. And then we can go to the simulation and results. Okay, save and continue. Here. For now, this will not work because I didn't set up the environment in detail, and I prepared a project here. So I'll select this one. It's, as you can see here, the same thing, just with more detailed positions of all the elements. Our bin is placed correctly, as well as the robot. Parameters, 35, 5 cycles, this looks good. And now we can start the simulation. We have 3 different options here: our feasibility study, which I've explained, our AI training for a computer vision, training-based computer vision approach, and the optimization, which is an upcoming feature we will realize based on the feasibility study. I will click on play immediately. You see now we have started simulation. Status not started yet, but now it's running. In the backend, and I will jump over to the simulation environment in a second. A lot of things start to happen. The simulation needs to set up itself. Yes. So it will start in a second, and I can explain what happened here. So we started simulation. We loaded everything we set up. We are calculating the grasping points, like Richard explained with our approach. We are calculating the important robot positions for the bin picking approach. We are setting up the path planner for this situation. Everything of this happens automatically. We wrap it up together, bring it back to BP3. BP3 now sets up itself. BP3, our bin picking solution. As you can see here, it now loaded the project, sets up everything itself, takes even the important information and gives it to our object detection server, which set up itself again. So everything automatically, just by a click, it started to work. And you see here now, BP3 is calculating the grasping points, and the simulation is executing. Let's jump in it for a second. Please excuse if there is some delay in the simulation. I'm currently streaming it on my PC, and we're streaming it live again. So we have a stream of a stream. So here you actually see the execution, and let's include BP3 again. So you see we are executing the grasp BP3 is happening. So important thing to mention here as well for the object detection part. We are using here a state-of-the-art non-training based object detection. I know I just introduced the training-based approach, but here we're using a non-training based approach. Still AI-based, but we don't need to train a separate network before we actually detect objects. This is a new approach which simplifies the complete setup of the system and the usage of the system. Of course, every object detection system has its limits, but to be honest, so far in our test, we couldn't find an object we are not able to detect immediately. But in case we are having problems detecting objects, we are still offering this training-based approach, so we can train an individual neural network focusing on these specific objects. Yes, and this is what we will do for quite a long time, looking at the simulation. Simulation is running, doing all the things. Once the bin is empty, couldn't find the grasp point anymore, or runs into other problems as well. Let's see if you can manage to get this one, because that's quite an hard one. Oh, yes, you did. Okay. This will happen for quite a while until the bin is empty. As you see here, additionally, we are using a new simulation environment compared to the slides you saw previously. We are using currently the NVIDIA simulation environments, Isaac Sim and Isaac Lab. Focusing on Isaac Lab because it has a GPU accelerated physics calculation, not only a GPU accelerated ray tracing, but also widget body GPU accelerated calculations, so it's way faster than usual running other systems. Yes, so important thing, hardware. I mean, we're seeing here a simulation. It is not that hardware heavy as you might expect. Currently, this system where we run the simulation, for the people who are a little bit familiar with graphics units, we are using a 3090 Ti, which is, to be honest, not a state-of-the-art graphics unit. So even with older ones, or even with ones with less memory, we can work with it. We have a separate computer here, or separate server, where our bin picking system currently works on. As you saw on Richard's slides, it's generally really modular. So this gives us the advantage that we can exchange different aspects, we can run it in different systems, and we can split the overall hardware requirements to different things. Yes, the detection server we're using, so object detection that you aware of it, will run on a similar system. Actually, in fact, it doesn't. The current object detection server is running on a 3090 Ti as well. It's quite fast, and we actually don't even need the complete RAM of the GPU. We can work with around about 8 GB of RAM on the system, which is normal state-of-the-art GPUs have way more RAM. So this is basically all from my side.